Okay, so let's get started, and so let me see if I'm recording. Yeah. So yeah, today what we'll do is uh, today we will focus on the uh, Ethereum. So we have seen briefly some of the concepts in the Ethereum, right? So last week, and we will continue, and we will see some of the important components in Ethereum, especially what is Ether, how it is produced, and how it is consumed. So we need to understand few basic rules there, and also about the nodes. And Ethereum always talks about this word state, like the Ethereum is a platform which is like a state transition systems. So it travels from one state to other state, and we will understand all the underlying things. And then what I will do is I will briefly touch upon Hyperledger Fabric. Again, we are not going to program anything with Hyperledger Fabric because it's a really complicated architecture. But my wish is to introduce you the basic high-level architecture, because it could be there is a probability that you guys will be working when you go to the industry after you finishing your graduate studies and things like that. And when you start working on the blockchain, probably this is the platform where you can also maybe interact with and develop smart contracts and chain code and other kinds of things, right? So that's why I included the Hyperledger high level architecture slides a bit on that. So that is the plan for today. And before going further, then there was last time there was some questions which I didn't have time to answer. There was a specific question about agroland, agrorand. So the question was about maybe let me read it, and then let me answer the questions, and then we can go further, right? So the question is about what is your take on networks like Algorand that are trying to allow developers to interact with the network using the Python, and how will the smart contracts dynamics change after that? Okay, so um, yeah, first of all, there are several platforms, right? So if you look into, just now I took this screenshot from the Google. I tried to search for smart contracts platforms, and then there are so many platforms, right? So, for example, Ethereum is one of the popular one, and Algorand and other kinds of Hyperledger. There are many several platforms. So the question is about they allow Python language like Python to create smart contracts and deploy on Algorand and things like that, right? So uh, that's perfectly fine. So far, if you look into the all the platforms which have big share, still, Ethereum is one which is having a lot of majority share in the smart contracts because of the ease and also because of the first mover advantage. If you compare with the blockchains or the cryptocurrencies, Bitcoin has the first mover advantage, right? So Bitcoin now risen into a state unbeatable, or you can say not unbeatable. Let me put it like this: unhackable, because when we were discussing about the Bitcoin also, as I was telling that Bitcoin has gained that momentum, and now it in a pretty big stage. Even if you want to hack the network of the Bitcoin, you need to really spend billions and billions of dollars in terms of the computing power and things like that. So it has the first mover advantage. Like that, Ethereum also has the first mover advantage. Again, there is a huge how can I say, market for decentralized contracts and things like that. So there might be several uh, platforms coming up, and based on the type of functionality they offer, based on the ease of deploying the smart contracts, and the base of the flexibility and other kinds of things, some platforms might become recognition, good recognition, and some may still say the same, right? I think Polygon is also one of the platforms which is really pushed from India a lot, because it can generate contracts for the multiple blockchains and things like that. So there could be several chances. And in that context, even Ethereum supports a language called similar to Python. So you cannot use Python, but there is a language which is supported for Ethereum, which is similar to the Python language or something like that. I think it's Viper or something like that, but there are languages. So to put a short answer, yes, it doesn't change anything dramatically, because Ethereum has the first mover advantage and also established advantage. And in my honest opinion, I think Ethereum survived these initial crashes, hacking, and other kinds of things, and it has regenerated into a new form. For example, moving away from proof of work to proof of stake is the biggest decision which they have taken. What is the advantage with that? They can reduce the energy consumption by 99.5%. So that means they become very, very energy efficient. So that is the biggest decision which they take to get survive. And if they would have continued on the proof of work like the old time before the merger, they might have been challenged by the other platforms, because these new platforms, for example, Algorand or Polygon and other kinds of platforms, they can come up with a very easy consensus mechanism which are energy efficient and things like that. But I think the moving to the proof of stake consensus mechanism was a big step for Ethereum to stay in the line. So in my guess, yeah, probably there will be other platforms picking up popularity, but maybe Ethereum will still maintain its supremacy for some more time. And then there was another question. Let me see. Yeah, we have to pay gas limit on NFTs. Yes, as we mentioned, when you create NFTs, you need to pay gas. That's okay. We had NFF flash. And there was one question about when will we start programming smart contracts? Yes. So to answer that, so we are this week we will finish the architecture. So that means we will put a full stop to the looking at the architectures, and from next week onwards we will focus on programming, smart contract programming. Again, I was in bit dilemma to introduce JavaScript or not. So I don't know how many of you are familiar with JavaScript. So my dilemma is that if you know JavaScript, then we can straight away jump and go to the Solidity programming, the programming for smart contracts. But if you don't know JavaScript, then maybe we can spend one class on the JavaScript as well. I can give some quick introduction to JavaScript, just only one class introduction. Any opinion on that? Okay,
Professor,
should we have
I think the particular student, no, the particular student might be in the culturals. That's what I have told. I will ask him to see the recording.
Okay. And then
Yeah.
my question is, do we dedicate one class for JavaScript, or should we go with Solidity programming?
Yeah, students, what's your opinion? Do we need a class for JavaScript?
So will one class of JavaScript be enough to start Solidity programming?
Yeah, again, I'm not going to teach I'm not okay. If my initial plan is to talk about JavaScript for one class, right? So because again, my focus is not teaching you JavaScript by step from Hello World, but I would rather speak about the functional features of the JavaScript. So for example, function closures and higher order functions. So all the advanced features of the JavaScript. So, and again, D3 library, which we will use, not D3, the Node 3 library, which we will use. Sorry, Web3 library, which we will use. So my idea is that just to introduce some high level advanced features of JavaScript, and then start with the Solidity code.
Is that okay? So I think some have posted in the chat box that they are quite comfortable even with directly going with the Solidity. But still, Professor, we can go, as you said, we can go with the functional features of JavaScript for one class and move on with Solidity.
Okay, then let us decide. Let us say that on Monday I will talk about the JavaScript again. I will make sure that you don't get bored, right? So I will show you some hacky features and how to develop classes and namespaces which is not exist in the JavaScript and things like that. So let's spend time on it because it's probably useful for your programming skills and things like that. And then next Thursday we will start with Solidity programming. Okay, so let's go further, and there are no more questions. So yeah, so again, based on let me quickly recap the smart contract, and based on the last question, last class question, I got an impression that I was not very clear about smart contracts and the execution of the smart contracts when I was initially introducing, right, the life cycle of the smart contracts and things like that. So again, I picked an example to give a concretely simple illustration of what a smart contract is. So at a basic level, you can think of it like a smart contract is nothing but some kind of vending machine, right? So what is a vending machine? You have some products and you have some actions you can make. So for example, you can input some coins and then you can get the bottle of Coke, or you can input more coins, maybe you can get a packet of chips and things like that. It indicates that there is some kind of interface where you can do different actions, right? Different actions with the different inputs. And based on the type of action you call for and type of input you have, then it can decide that, okay, whether it gives you the drink and some change back if you put more money, or it can give you only the drink if you put the proper change, exact change and things like that. If you put lesser money, probably it doesn't respond and things like that. So it's a quite similar way a smart contract also works. So first of all, a smart contract is a script which we deploy on the blockchain, right? So and then what we do is when the deployment is done, we just invoke the functions on the smart contract. I don't know how many of you know about web services programming or web programming. When you develop web services, what we expose is a contract, right? So we have a contract which contains some functions, remote procedure calls, you can say, and that is exactly the same things goes with the smart contract. Smart contract is also similar to a web service which contains some functions, and you call them with proper inputs and similar to that mechanism, right? So smart contracts, we call them with some parameters and it will perform some actions or computation if certain conditions are satisfied, right? That is the one thing. We specify the conditions in the smart contract when it has to do something and stuff like that. So for example, we have a simple vendor smart contract, which could be, we invoke it by sending the transaction or something like that. And then it can, as a result of it, it can maybe transfer a digital asset from one person to other person or something like that, right? So this is an example for smart contract. Again, there are two stages where we develop the contract, we test the contract, and we deploy it. So that is like somebody making a vending machine, preparing vending machine, and making sure that it works, and put all the items which it is supposed to do it and things like that, and installing, putting it in your campus for your usage, right? So that is all the deployment stage comes in. And when once it is deployed, and people will use it, right? So people will go to the machine and put a coin and get a Coke bottle or something like that, similar to that. When once the contract is deployed on the smart contracts, you can call with the proper input values, right? So depends upon the input values and depends upon the conditions in the smart contract, it might do some work for you, right? Transferring coins or doing some service or sending a message and whatever it may be. Okay, so any questions on that or comments or anything need to be clarified? Okay, so if you have any questions, put it in the chat, right? So I'm also watching the chat. So let us look into some of the fundamentals of the Ether. we discussed about the gas prices and the gas. We discussed that we need to pay some money in the form of gas and ether, right? In the form of ether and things like that. Let's understand how the internal workings of the ether, or you can say the fundamentals of the ether. So first of all, ether is a cryptocurrency used in the Ethereum. So this is the form of the currency which is used for doing the transactions and other kinds of things. So fundamentally, ether is only the accepted form of payment for transaction. If you want to get done things on the Ethereum, the only way you can do is you can pay the transaction fee using ether, and then only you can get the things done, right? So this is the only one form of the payment accepted on the Ethereum. And then the second point is ether is also required to validate and propose blocks on the mainnet. What does it mean? So when you actually create a block, you need to deposit some ether as some sort of the deposit to make sure that the node doesn't behave maliciously. What does it mean? It means, for example, if the node want to do mining in the Ethereum network, it has to deposit some money as a guarantee. So in this case, it is 32 ethers. We will see a bit later. So even for validating and proposing a block, you need ether. Of course, you don't spend all the ether, but you keep this ether, this much of the money as a deposit for even for joining the node and performing the actions, performing the validations and things like that, block and things like that. So, and also ether is also used as a primary form of collateral in the DeFi, decentralized financing, in the lending market as a unit of account for NFTs, and also payment for earning services and whatnot, right? So it is the default form of monetary or the cryptocurrency on the ether. So what is the collateral? Maybe this is a term which you might be unfamiliar. So a collateral is nothing but some kind of guarantee. So for example, if you are going to the bank and taking a loan on it, you need to show some collateral for them. That means if the bank need to give you money, then they need to know you that you don't run away, you will pay. So they will ask you to provide some security or guarantee, right? So that is nothing but the collateral. So even in case of decentralized finance, we are not touching that. This is a pretty big subject, how to use blockchain and decentralized programming for offering various financial services like the shorting and lending and many kinds of financial actions. So that's called the decentralized finance. So there also ether is used as the form of the currency, even for the collateral. So even if you want to get a loan on the decentralized platforms, then you need to show a deposit of the ether or the account which is holding the ether as some kind of guarantee to get loans on it, right? So, and also ether supports pricing mechanism on the Ethereum computing power. And whenever the user want to make a transaction, he must pay ether to their transaction so that the transaction is validated and put it onto blockchain. Many times, if we make comparison against the Bitcoin scripting language is very limited. It doesn't allow loops, so that is not. So that's why it is not Turing complete. Since it's not Turing complete, the Bitcoin don't have big problems with the scripting language. What does it mean? Even if you want to create a malicious code or code that can do malicious things, you cannot do it, because the power of the scripting in the Bitcoin language is very limited. But on the other hand, Ethereum is a Turing complete language. So that means it's a full-fledged programming language like maybe Java, C# and other kinds of languages. It has the loops and other kinds of things. So people can easily misuse it. Suppose, let us say that we write a smart contract which has some kind of infinite loop, right? And let's forget about these gas fees and other kinds of things. Let's assume that the noders or the miners or the clients, they start executing this contract, right? So since it's an infinite loop, it will be ending up eating all the resources because it will never come out of it. Right, so that is one of the biggest challenge for the Ethereum at the time of design, because how to avoid the malicious behavior and how to discourage people to write buggy contacts and waste resources, right? So then they come up with some kind of scheme where they have to pay for computation. They have to pay proportional fees for the computation so that the transactions are verified and put into the blockchain. And so therefore, even if you write a buggy code, let's say you have an infinite loop in the smart contract, since you have to pay gas for it for each step of execution, and the execution model, as we have seen last time, it goes step by step in a stack-based programming language. So whenever the amount of gas used dedicated to the transaction runs out, it will simply kick it out and say that the transaction has failed. Right, so this is a kind of guarantee not to misuse the network resources. So that's why this ether and gas computation pipes are in place to take care and safeguard the network. So let us understand how ether is produced. Right, so ether is produced by minting the ether. So what is minting? Minting is nothing but the process of creating new ether. And it can only be created by the Ethereum protocol. So even if the users or whoever want to create, they cannot create it because it is like the Bitcoin. Also like the Bitcoin, the Bitcoins can only be created using the creation of new blocks and things like that. So similar to that, Ether is only generated when you create a new block or when you do the validation and block propagation, right? So this is what happens. And how does new ether will generate? So when you make a block, again, we'll talk a bit briefly about how the blocks are made and things like that. Now, previously, it is the proof of work, right? So everybody will compete to make a block. And then Ethereum has a time span of 15 seconds previously or something like that. And within this 15 seconds time, the nodes can compute and create a block, and the node which is accepted by the most of the other nodes will make it to the longest chain. And we discussed about the probabilistic finality of the longest chain and other kinds of things. So those things used to work like in case of proof of work. When Ethereum moved to the proof of stake, so then what we have is you have this the Raft algorithm, the consensus mechanism. So basically, you have a set of validating nodes. Again, who are the validated nodes? The nodes which deposit some money. So in this case, 32 Ether. I have a slide coming up later. So these nodes, they will be participating in the validation and proposing the block. And based on the validation nodes, one of the nodes will be picked up randomly to make a block. So here the nodes are not competing each other against making a block, but on the other hand, they were randomly selected. One of the node is randomly selected for making the block. So then the block will, let's say that this block is selected as, this node is selected as a block proposer. Then it will put all the transactions and make a block and things like that. And all other nodes in the validated chain, or you can say validated group, they will verify each and every transaction in this block by following the same thing, right? So that is how things happen. And how does this ether generate it, right? So whenever you create a block, I think you get 5 ethers or something like that. That is the block fee. And the 5 ethers is not only given to the block proposer. And what happens is, I think 1/8 of the total issuance is go to the block proposer. So that means, let's say that you have 20 nodes participating in the validation and block proposing the activity. And then one node is picked up as a block proposer. So he will get 1/8 of the block reward. So if it is 5 ethers, maybe 5/8 of ether will go directly to the block proposer, right? And then the rest of the ether is distributed to the validating nodes. according to their share and according to their honesty and their verification, validation, and other kinds of things. What does it mean? So, for example, let's say that if we have a one node which didn't do any job, and then that node will not get this share of the block reward or something like that. So that's how it works, and no competition, no wastage of the resources. So that's why the blocks can be generated at a very fast pace and also verified at a very fast pace, right? So any question so far? So Ether is created to the block reward, right? So then there are other types of fees, the transaction fees, right? So remember when we are talking about the gas semantics last class, we were discussing that there are two types of fee. One is the what you call the base fee, and the other is the tip or the money you give to the priority fee, right? So it's called priority fee. This is nothing but a tip to the miner or something like that. So these are the two kinds of things, right? So the base fee will be spent or burnt, and the priority fee will be collected, because this is like nothing like a tip you give to the miner, so they will collect all the priority fee. So that is nothing but a recycling of ether. There is no new ether is being created, but on the other hand, they get this recycling of ether. Remember, we don't have the coins, we have the account-based ledger. So for example, if a block proposer creates a node, and there are, let's say that 0.05 Ether's version of the priority fee it has, then it will be transferred to its own account, right? So this priority fee will be transferred to the block proposer along with the share of 1/8 share of the block reward. Okay, so let's go further, and there is a question, I will answer it a bit later, right? So burning ether. So ether can be destroyed. How do we, ether is consumed, right? So the burning ether is like ether can be destroyed using the process of burning. So where ether is get burned, it gets removed from the circulation permanently, right? So this is nothing but a small cryptocurrency. So, and when do you burn ether? So for example, if you want your transaction to be verified and put it onto the blockchain, right? So then you specify, you pay for the transaction in the form of gas fee. So that is where the ether is burned, right? And remember, we discussed about two types of fees. So we have the base fee, which is decided based on the how big are the blocks in the last few blocks and things like that. And we have the priority fee, that is a tip you given to the minter, right? So the miner and things like that. So the base fee, which you pay for the transaction, will be burnt. So that means that will be taken care. So for example, let's say that a node is validating transactions, right? Then what it will do is it will run the transaction, whatever the base fee available as part of the transaction, right? So that will be spent, and it will be destroyed, and it will be burnt. So burning the base fee hinders the block producer's ability to manipulate the transaction. Why do we want to burn the base fee, right? So we are allowing the tips or the priority fee to be collected by the nodes. And why do we need to burn the base fee? Because we want nodes to behave transparently. We don't want any kind of malpractice. So that's why whatever the fee you need to pay for the execution of the transaction, in terms of the resources consumed for the computing power and other kinds of things, this is the base fee, and this base fee has to be paid by each and every transaction. Otherwise, what happens is the nodes can play some politics, so they can include the transaction fees. Let's say that the base fee is also collected by the block proposer, right? Then the block proposer, when it includes the transaction, it can include its own transaction, because it doesn't need to give the base fee and take base fee and things like that. or it can give some refund, or it can give some concession to some of the transactions in the form of the base fee, or it can charge a higher base fee for some of the transactions. All these malpractices will come into play, right? So that's why they made it very clear that you need to have the base fee, which need to be spent or burnt while verifying the transaction. So that makes it very transparent. So everybody has to pay it. So no kinds of malpractices can happen. So, and again, how do you transfer Ether? So before going further, there is a question. Let me answer this one, right? So what are the disadvantages of this consensus mechanism? I don't see any kind of disadvantages. Let me roll back here. Next slide, I guess. Yeah. So first of all, the disadvantage is you cannot hide your identity, right? So when you have the stakes, you at least need to have your identity. Identity means nobody is going to verify your passport or something like that, but people know since you have a stake, so people know who you are, and so that is compromised. Remember, in case of Bitcoin, ignore about all the energy consumption and proof of work disadvantage with proof of work. Bitcoin nodes were very much decentralized, or you can say in the sense that anybody can join the mining pool. If you can run a Bitcoin mining node, there is software called some Bitcoin Qt or something like that, and then you can start mining the Bitcoin. Of course, it's a different story whether you're able to make a block or not by competing with all big giants who are doing mining. But on the other hand, you have no threshold to get into entry. In this case, even if you want to participate in the validated node, or if you want to participate as a block proposer, you need to pay 32 ethers, which will be around 125,000 US dollars. So it's a huge amount of money, right? So then you need to deposit, and you cannot hide your identity. So that means this is like a opaque channel where people can this is like a transparent channel where people can observe and things like that. So that is one of the disadvantages. On the other hand, it enhances the transaction cost. It enhances the transaction processing times very much. The most important thing is it's very energy efficient. The Ethereum got so much name after moving to proof of stake, because everyone who were hating the decentralized the programming and things like that, they were always pointing out to this deficiency of huge energy consumption. So in that sense, it has advantages. Maybe the disadvantage is that you cannot hide your identity. So the anonymity has gone. That has been spared. Again, it depends upon the use case, what anonymity you want and things like that. So that is one disadvantage which I notice. Okay, so how do you transfer? Okay, so there is another question. Yes, let's take these questions, right? So what are the disadvantages we answered? I didn't understand either minting. Can I unmute and ask my question? Please go ahead. Yes, ask question. Dia. Yeah, you can ask question.
Dia?
Ma'am, I think someone is changing the names and typing the messages in the
Okay,
chat.
okay, Dia. Okay, Dia.
Okay.
I
Okay.
think,
Okay. So,
yeah, it's okay, Professor. You can skip the question. Yeah.
okay. Okay. And then
Thank you, ma'am.
another question. Yeah, another question. What if someone can
Okay.
bribe someone to attack the network? So yeah, if you bribe someone, let us say that if you want to attack a network, right? So yeah, you need to bribe them sufficiently. So for example, maybe 500 million crowns or something like that if you want to attack a network like Ethereum, because you need huge amount of power and things like that, right? Remember, we are talking about the stakes. Let's say that maybe let me roll back here. Let's say that we have one of the nodes. Let's say that we have this node, right? He was having malicious thoughts to attack the network and things like that. He deposits his 32 Ether, which is like a 125,000 US dollars. It's not much, right? But on the other hand, he will be blocked and he will be penalized, right? So he will be prevented from participating in the node. You might argue that he can download the another node and create another identity, then buy this 125 Ethers, 125,000 equivalent of Ether, and then participate into the validators and things like that. You can keep on doing that. But since if you have the majority of nodes behaving honestly, then there is no problem, right? So it's not easy. You have to bribe huge amount of money so that he can attack the network. You can easily create an attack, but you will be banned from the network immediately, right? So if you want to create a quite big attack, either you should find a bug, something like the DAO attack, where there was a bug in the software. Otherwise, you will end up wasting a huge amount of resources without any effect on that one. Okay, so let's go further. Then transferring Ether. So again, Ether is the cryptocurrency in the Ethereum blockchain, right? So that means even if you want to transfer money from one account to another account, that will be done in the form of Ether, right? So each transaction contains a field. I think I have the, each transaction contains a field, value field. So, sorry. So how do you transfer Ether from one account to other? When you create a transaction, it contains a value field, and you will specify in the value field how much Ether you need to transfer to other account. Let's say that you are transferring to your friend 1 Ether, then you will put the value as 1 Ether and plus transaction fee. And then you specify the transaction fee and other kinds of things, and you send the transaction to transfer the money, right? So that is the one. And let us say that you are calling a smart contract or you are invoking a smart contract. Then what you do is, in the recipient's address, you will give the address of the smart contract. So that itself indicates that you are transferring this Ether to that smart contract to get some work done. Remember again, the vending machine, you are putting a coin into the vending machine to get something out. So similar to that, you are calling a smart contract and paying for the gas. And then the value field in the transaction will contain the gas cost, right? So the amount you need to execute this smart contract will be part of this transaction. So how do you find how much Ether you have? For example, people will query. So querying Ether, basically you have different APIs, or you can say web pages. For example, Etherscan is a web page which actually queries the nodes and get the balances for you. Remember, all the nodes, at least the nodes who participate in the validation and block proposer, they have the full state of all the accounts. So that means, let's say that if you want to find out how much money you have in your account, right? The way you do it is you just get the state from the node, one of the nodes. And the nodes will contain this it is nothing but you have this bank account ledger containing which account containing what and how much and things like that. This is replicated across all the nodes, right? So this is an example about how to see how much Ether you have. This is from the Ethereum Foundation. I think they have you can see a huge amount of Ether, right? So 300,000 of Ether and things like that. Okay, so let's we discussed about there are two types of accounts, right? Let's briefly also touch upon the type of accounts. So you have externally owned accounts. So that means these are the accounts, normal accounts, right? Used by the people and things like that. So creating an account doesn't charge anything because you are creating just an account. This is like a wallet, right? Your wallet contains multiple accounts, and you can create an account like that. And if you have an account, you can initiate transactions, and you can also create transactions between owned accounts by Ether or transfer token. So that means, let's say that you can create a transaction between two externally owned accounts, right? And so when you make a transaction, what happens is each externally owned accounts, they will contain public and private key pairs, like what we have seen in the Bitcoin system, right? You need your private key to spend money. Similar to that, you need your private key to create a transaction, because to make sure that you are the authority of this account and things like that. On the other hand, smart contract accounts, they don't have any kind of public-private key, so they don't have it, and they have the code, everything specified in the code execution and things like that. They have the rules. First of all, creating a smart contract is will requires cost, right? So that means what happens is you develop a smart contract, you test it, and once the smart contract is ready for deployment, what you will do is you will create a transaction for creating the smart contract. So you will pay some gas fee, because you are actually storing something permanently on the blockchain. A contract deployed on the blockchain is like a permanent record, right? So it creates a permanent record. So creating a contract has some cost based on the type of operations it has, based on the logic and the number of computational units it requires to execute the contract, right? Can only send transactions between the in response to receiving to transaction. So this is an important issue. Remember, we have two types of accounts. The owned accounts, they can create transaction at any point of time. These are like a normal bank account, right? So if you have a bank account, if you have money in the bank account, you can withdraw at any point of time. No issues, right? So you can use online banking, or you can go to the bank, or whatever it may be, or you can go to a ATM machine or something like that. You have the right to withdraw money from your account. So the externally owned accounts are also like that. But when you come to the smart contract account, these are not real accounts, you can say, right? These are web services. In a sense, these are nothing but the web services. Or to be more accurate, we can call them as the remote procedure calls. In computer science, we call them as a remote procedure calls. So that means this is nothing but a function which is available on certain IP address, which you call and send some input information so that you can get the work done, right? So that is the reason smart contracts cannot initiate a transaction. So they always, like the web services, they wait for some event to happen to invoke a transaction. So that means you need to call them to make a transaction. So many times what happens is either the externally owned accounts or the another smart contract account will call the smart contract account, and then it will do some job, and it will do whatever the transfers you need to do, right? And transactions from the external accounts to a contract can trigger a code. So that means that's how it is called. And contracts don't have the private keys. They are controlled by the logic in the code. So what do you have in the account? We have seen this slide last time. I was discussing it briefly. You have a nonce. This is nothing but an index number, which will increment for each transaction you create from that account, right? So this is like just like a ledger, right? So you have your own account, you have the ledger, like a bank ledger. So this is like a series number, or you can say ID, right? So 1, 2, 3, basically it's a nonce. And then you have the balance, which gives you the how many number of tokens or the ether you have in the account and things like that. And you have the storage hash. What this means, so it will, let us say that you made 10 transactions from this account, right? Then all the transactions will be stored in this storage account using the Merkle Patricia tree, and this hash value will be stored, right? So each account contains also the history of whatever the transactions it made. And finally, if the account is a smart contract account, it also has the code hash. So that means it has some EVM code, smart contract written in one of the supported languages, which is compiled to EVM code, and the hash of the EVM code is available. Yeah, so that's how it happens. And if it's a normal externally owned account, so you just have a hash of a empty value or a null value for code hash, because it doesn't contain any smart contracting code. And then let's also drill down a bit into the transactions, right? So what are the Ethereum transactions? The transaction refers to an action initiated by the externally owned account. So that means only externally owned accounts can initiate a transaction. And let's say that if Bob wants to transfer 1 Ether to Alice, then he will create a transaction. It contains this money information. So from and to, from the Bob's account to Alice's account, right? So these are the addresses which they will use, and the signature of the Bob, because Bob is transferring money, and also nonce. This is nothing but the index number for the Bob account, right? So where the transaction is created, the value, the amount of the money you are transferring to the recipient, input data, some other thing, and we have this gas limit and max priority fee and max feed for gas and things like that. Remember, I was also mentioning that it is very hard to estimate how much exactly is the gas needed to execute the transaction, because it involves certain uncertainties. The reason is, maybe you can easily compute the number of computational operations required in the smart contract based on the smart contract code. Many IDEs do that. So this will need, let's say that 100 gas steps or something like that, or 25,000 gas steps or something like that. But the base fee and the priority fee, they are changeable, right? So base fee is decided by the how much load you have on the last few days, and on the other hand, the priority fee is the tip. So that's why always you try to specify what is the maximum value you want to pay for the transaction and things like that. So, and the transaction life cycle. So whenever you create a transaction, you have a cryptographically signed hash will be generated and things like that with a public private key and other kinds of things. And the transaction will be sent to the network. You can say broadcasted to network. So the nodes which listen for the transactions, they will receive it and they will put it to the memory pool. So this is nothing but equivalent to a unspent transaction pool in case of Bitcoin, right? All the transactions will be stored, and a node will be chosen to do propose a block. So that will, what it will do is, it will verify the transaction and it will make into a block, and the block will be generated. Remember, we have no competition for the block generation here, because the node is picked by the validators or the consortium of validators. So they will generate the block, and once the block is released to the network, or before the release it, finalize it, and release it to the network, it will be validated by the validators. So that is, the validator's role is quite important here. So the block created by the block proposer will be validated by the other nodes. What does it mean? They will simply take the block, they will take each and individual transaction, and they will execute these transactions in their node. So that means they just don't copy block and add the block to their chain. They will verify each and every transaction, and then if everything goes well, then they will add this block to their local copy of the blockchain or the chain, and then they will transmit it to the network. So that's why when once it is finalized and send it to the network, it gets confirmation, then only the transaction is finalized, right? So that is the normal flow which you have here. Okay, so let's quickly look into some of the blocks, EVM nodes, and the clients. So a little bit about the how it operates. So blocks are the batches of the transaction. So with a hash of the previous block. So similar to what we have seen the block architecture in Bitcoin. So here also we have the same, you have the block and there is a hash linking to the previous block and things like that. So to ensure that all participants on the Ethereum maintain the synchronized state, so all the transactions and put grouped into the blocks, and the block will be verified and put into the block, right? So you can say that these are the steps of synchronization, right? So that means you have different nodes. When you have a state-based model, where state is triggered by the transition between the different states, what happens is all the nodes will come into some kind of consensus. So the consensus here happens is at the block level. So that means whenever the block is realized and finalized, verified, and put into the blockchain, so that is where all the nodes will come into the same kind of world state understanding, right? So the blocks are created in an interval of 12 seconds. So that is we call them as slots. So, and in each slot, a single validator is selected. So that means a validator node, let's say that there are 12 validator nodes or 15 validator nodes participating in the network, and one of them will be picked up randomly, and then they will be assigned to do the job of creating block, right? So then they will create a block within the 12 seconds, and then after 12 seconds, again, new slot will come, right? So, and sometimes what happens is if the node is inactive, or you can say maybe might have some technical difficulties, because 12 seconds is a very, very small amount of time, right? So let us say that one node is chosen for making a block, then it didn't respond on time, so the block will not be generated in the 12 seconds, right? So then you might have some empty slots in the block, so they will be left over, right? So when you look into the slots, then let's say that if the validator node fails to make a block, the next slot, let's say that another validator node was chosen to make a block, then what it will do is, it will, rather than, since the block is not created in the previous slot, it will point its block to the previous block, right? So that is how the chaining works. So sometimes you can also have the holes. And this is the proof of stake protocol. So every validator node need to deposit this 32 ETH, right? So this is 32 ethers, which is like $125,000. This is the deposit you put as a collateral against the bad behavior, right? So if the node behaves correctly, there is no problem with the deposit. The deposit will be, they will get back deposit if they want to fit the network and go out of the validation, right? But on the other hand, if the node performs any bad behavior, so for example, it tries to include a transaction which is not valid, that is called a bad behavior. And then what happens is these 32 ethers will be confiscated, right? And then, so then it will be against a bad behavior, then they cannot do it in a persistent manner, right? So they can maybe do it for 1 or 2 times, but if they want to do it for a long amount of time, they need a huge amount of money to be wasted. So every slot, a validator node is randomly selected, called the block proposer, and then they will make the block, and all the validator nodes who hear about the new block, they will re-execute the transaction. So this is quite important. They just don't only check the state, they will re-execute the transaction. So that means the state will be verified and added to the local, right? So each transaction will be executed, the logic and other kinds of things. So, and then that's how it is verified. Remember, re-execution means, let us say that I am transferring 1 ether to my friend. Let's say that there are 10 nodes, validated nodes, who are validating my transaction. They will re-execute it. It doesn't mean that 10 times the money will be deducted, right? So re-execution means they will take the account status. Let's say that I have 7 ethers in the account, and then they will check how much money I have it, and then they will execute the transaction in a node, and the node will say that, okay, previously he has 7, and now after the transaction he will have 6, right? So the same kind of state will be reached at all the validated nodes. So that is called the re-execution, right? So that's how the things work. And finally, when if a validated node hear about the 2 conflicting blocks, you can also have the chance of two conflicting nodes, right? So because 12 seconds is a small time, let's say that a previous validator node fails to generate the block in the dedicated time. Maybe it got delayed, and then you might end up with two blocks coming up. And then how do they resolve? They use this fork choice algorithm. So pick the longest chain, and then they will resolve it and things like that. So when they move to proof of work, it is not a big problem nowadays. So you might get one or two forks, but they will be resolved in just in the next two iterations or something like that. So one thing about it, we also discussed the block size. You can only have the maximum amount of block size is decided by the amount of included in gas. This gas is the transaction fees, right? So the fees required to execute the block, that is the block gas we call it as. It is not about if I'm transferring 1 ether to my friend, that is not included into this, right? So this is only the amount of gas required to execute all the transactions which are included in the block, right? So just 1 second, there are some messages. What if one validator validates the block and the other validator invalidates the same block? Then if the block is accepted or going to be rejected. Yes. So what happens here it is, so there is no two ways of going here, right? Either that means there is only one truth. There cannot be two truth, right? So for example, let's take this case. Let's say that if one node validates perfectly and gives acceptance, and let's imagine that the other node says that the block is faulty, right? Who is correct? You have a pool of validator nodes, and they will execute it. And in these two nodes, among these two nodes, one of them must be wrong, right? Because let's say that the block is perfectly made, no issues at all, right? And then all the n-1 validators, they will approve the block. So then we see that this one node, which says that the block is fault, it is his fault, and he is trying to do some malicious behavior. Probably he will lose his 32 ether because he tried to make a mistake. Let's take the converse case. Let's say that we have two nodes, two validator nodes. One says right, one says wrong, right? Let's imagine that the block is faulty, right? When we look into the other validator nodes to get the consensus, and the other validator nodes also, n-minus validator nodes, they will say that the block is faulty. It has a faulty transaction, right? Then what happens is the node which says that the block is right, their 32 ether will be forfeited. They confiscated, and then they will get, so that is the punishment you can get if you are dishonest in making the validation. So we cannot go into two paths because there is only one truth, either fault or either the block is correct. And the block size, so we have 15 million, and then it can go up to 30 million gas units. That means twice block size. Remember, we were discussing that they have a scheme to discourage the indefinitely increasing the block size. When the network is under very much pressure, you have a lot of transactions to put, and the blocks can go up to 30 million gas. So that means they can go up to 2 times the normal block size. But they have to go with this scheme. So if they are in the 30 million block size, they have to increase the base fee by 12.5% in each iteration, right? So for example, if this continues for maybe 15 times or something like that, then what happens is the base price becomes quite expensive. And then people who want to get the transactions executed, they will wait for some time, right? So now the trading is quite high. So the prices are quite high. Let us wait for a half an hour, right? So to get your transaction executed. And since the prices are going very high, then you will wait for some time, and the load will decrease. And if the weight of the block size decreases, and then the base price also decreases. So what are the blocks? Okay, blocks are nothing but you have these transactions which are packed into block, right? So basically, it's like a block in kind of Bitcoin, where you have the transaction, where you have header, and those kinds of things, more or less in the similar same structure, where you have the transactions put into it. I think I have one example where, yeah, you have here we have. So a block is nothing but containing a series of transactions and some header and things like that. And then I was talking more about what is the difference between Bitcoin and Ethereum, right? Bitcoin is a kind of cryptocurrency. So we have the blocks, we have the coins, and remember we have the transaction-based ledger in Bitcoin. But in case of Ethereum, it also has some kind of notion cryptocurrency called Ether, which is used to spend and things like that. But on the other hand, it also have this more powerful mechanism of smart contracts. Remember, for making smart contracts to work efficiently, we needed to move from transaction-based ledger to account-based ledger, because now we need to take care of the account balances and things like that. Otherwise, it's not possible to execute the smart contract in a much efficient way and things like that. So that's why the Ethereum is called a state machine. So what is state machine? It is nothing but a computational model. So in computer science models, you have different state machine models. So basically, it means that you are in a one state, right? And then you have some kind of transaction, or you can say you have some kind of state change happening, and then it will move to the other state. And so that is how it is pursued as a state machine, right? You move from one state to other. That is the main idea behind it. So Ethereum state is nothing but a large data structure that holds not only all the accounts and balances, but also about the machine state, and which can change from block to block. So whenever you add a new block, then the Ethereum state machine goes from one account to other account. I have a few more slides to explain it a bit further, right? So the rules, how the state changes from one state to other state is defined by the EVM. That means Ethereum virtual machine. Right? So this is how the state can change. First of all, what is a state? So we call it as world state. What does it mean? It is nothing but it is the copy of the network with all the accounts on the Ethereum with their appropriate balances, addresses, and everything, right? So let us say that you have a bank, and the bank has the ledger containing all the people, all the account holders. So if you carry that ledger, that is the world state of the bank for that business, right? So similar to that. So in case of Ethereum, a world state is not a state at certain point of the time, is nothing but it contains all the accounts and all the information about the accounts, right? So how much balance you have and things like that. So that is called the world state. And the account could be a smart contract, or it could be a normal externally owned account. No issues at all. Let's see what happens when you create a contract, right? Now we are in the creation phase. So let's say that the world state is at sigma t, right? So that is the current world state. Now I created a now I created a smart contract, and I deployed it on the network, right? Remember, this is a gas spending transaction because you need to pay for creating the pay for deploying the contract to the network, right? So if you look into the state, we have all the accounts and their balances and all other information, right? So this is the current state. When I create the transaction, when I create the smart contract and deploy it to the network by paying some gas and things like that, now let's see what happens to the state. So now we move to a new state, lambda t plus 1. So the state at t plus 1 time step, which contains this newly deployed contract, right? So how it looks like, you have an address where the contract will be listening for, and you have an account attached to the address, which contains a hash code of the transactions and a hash code of the smart contract code, right? So now the state has changed from lambda t to lambda t plus, right? T plus 1, right? So sorry, sigma t to sigma t plus 1 steps. Let's say that what happens when we invoke a smart contract? Now we are in this step. Let's say that this is the sigma t steps, where we have the smart contract already deployed, listening at the address n, and which has the code of specifying what should it do and things like that. And then let me say that I send a message call. I create a transaction from my own externally owned account to this smart contract, right? So what happens here? So now we move to a new state, sigma t plus 1 state, where we have the same contract. Nothing has changed in the smart contract because it's already stored there and it already has the code. There is no change in the code, perfectly fine. But on the other hand, you can see that the result of executing the smart contract has made some changes in the storage space. What does it mean? So for example, let's say that the smart contract transfers some money to the another contract or something like that. So that is the job of the function, right? So then the balance of this, the account balance of the smart contract will change. This is like, again, let me bring this vending machine example, right? I really like this example because it's easy, simple to explain. Let's imagine that we are at the vending machine, right? So it has some Coke bottles and food and everything in the vending machine. Now I will go to the vending machine, right? So it has the contract already. So what is the contract it has? So if I pay 5 rupees, it will give me a bottle of water, right? So that let's take the simple step, right? So that is the kind of action which I'm instantiating. So I put the 5 rupees into the vending machine, and then what happens? Then the balance will change. Maybe the balance will its balance will go by 5 rupees more, and then it will give me the Coke bottle. So also the storage of the Coke bottles, you can say inventory of the Coke bottles will go down, and this is the state change which will have. This is the change which will happen, which leads to a new state change, right? So now the vending machine, previously having the 10 Coke bottles and a certain X amount of cash, moving to a state containing 9 Coke bottles and X plus 5 rupees of cash, right? So that's how this is seen as a state machine transitions, right? Okay, so let's briefly touch upon nodes and clients. So any questions so far? Okay, so let's quickly look into the nodes and clients a bit. So basically, Ethereum is nothing but a network of nodes. You have a network of computers running a software, which their job is to verify the transactions and prepare block and things like that, right? So a node is nothing but an instance of Ethereum client. So you can also call it the client, but based on the type of job it does, it will contain different clients, right? So what is a client? First of all, a client is nothing but an implementation of Ethereum that verifies data against the protocol. So basically, it is nothing but a piece of software which executes the rule according to this virtual machine, right? So Ethereum virtual machine, EVM. So there are two types of clients, execution clients and consensus clients. What is an execution client? So this is also called the execution engine. So basically, it will list for the new transactions, and it will verify the transactions, and it will listen for the new transactions broadcasted to the network and executes on the VPM and hold the latest state and the database of all Ethereum data. So basically, it is nothing but a client who knows the rules of execution of a transaction, right? This is the one which understand the rules of the smart contract and the rules of the executing the smart contract. For example, the execution code might contain a step saying, computation step saying that maybe transfer 1 ether from Bob to Alice, and then it will do that job, right? And then there are other type of clients, which are consensus clients. Even in Ethereum 2.0, which is called the Ethereum 2.0, right? So the execution client is more or less the same thing, right? So because what is execution client? it knows how to validate the transaction and make the block, like putting the block pointer or block header to the previous block and all other kinds of things. These are intact, the same kind of thing. So the consensus client, which is called the beacon node, remember we were discussing about this ledger and things like that. So this is the new consensus layer, which is now added to the Ethereum 2.0, right? The consensus node, it implements a proof of stake algorithm, which is the current consensus algorithm, and which enables the network to achieve agreement. So this is the one which is playing the role of validator node and proposing the block and all other kinds of things. And maybe you might also have the third piece of software, which is called the validator nodes. This is a node which actually maybe validate the nodes. Probably they don't want to participate in the block proposal, but they can verify the transactions and things like that. So these are three types of clients you have in the Ethereum. And you can have different types of nodes. So for example, full node. What is a full node? This is a node which actually does mining, right? So does mining means this will collect the transactions. It will have both the execution client and also consensus client and all other things, right? So basically it stores the full blockchain data. So full blockchain data means probably not until the Genesis block, but most of the full nodes, what they do is they basically use, they basically store the recent 128 blocks or something like that. And then they can prune the other previous data so that they can perform efficiently. But let's say that if you have a transaction which is pointing to a very, very long block, then they can get the information and things like that. And they participate in the block validation. So verifies all the blocks and all the blocks and also the transactions. And all states either received from the local storage or regenerated by the snapshots of the full node. So again, as I mentioned before, as part of the validation, they take each step of transaction and then they re-execute it to reach to a new state, right? So, so that means they will somehow re-execute all the transactions in their local EVM to attain at the same level as other validator. If they don't agree, there must be something wrong, and then it needs to be resolved and things like that. And serves the networks and provides the data on request and things like that. So another way to restore a full node, let's say that you are a new node joining to the network and you want to mine Ethereum, right? So since you are not participating in the previous blocks and you don't have any information, so what you do is you will get the snapshot by full node. So we have the archive node, which contains all the nodes. Sorry, archive nodes contains the full nodes, but at each step of the full node, what does it mean? So basically, they contain all the node information right from the Genesis block till the latest block. Not only that, they contain this information in the series of snapshots. So for example, they take a snapshot at the Genesis block. They take a snapshot when the first block was added after that. And then they take a snapshot when the second block is added. So for each new block, you will have a copy, right? Of course, this might be a wastage of time, space and things like that, but this will also help us to look into the history and see what happened, right? For example, if you want to find out how much account balance is, how much is the balance for an account XYZ, for example, at 4 million blocks, what is the balance and things like that. So you go to your archive node and pick up the snapshot at the 4 millionth blocks snapshot, and you can verify it, right? So this is needed. Otherwise, what happens is nodes may crash, and the full nodes are also not maintaining the full record. So they only have the recent data. So then you might run into big problems if you don't have an archival node maintaining several archival node maintaining the copies of the blockchain. And this is not the same what happens in Bitcoin. In case of Bitcoin, when you want to do mining, you need to have full information right from the Genesis block until the recent block. There is no other way, because the Bitcoin works in a very completely decentralized fashion where there is no trust, right? So, but here things happen because of the proof of the stake. They trust the peers and they trust these snapshots. So that's why the nodes can be a bit flexible, only storing the information about some last recent nodes, right? So, but whenever they want, they can easily get it and things like that. So they are not in a distrustful mode like the Bitcoin. Finally, you can have a light mode. What is a light mode? That is nothing but a node which don't download the whole block, but it will only download the block headers, which will be used for checking information and things like that. Similar to Bitcoin, you also have the light nodes in case of Bitcoin mining, not mining, where they want to verify a transaction. Light nodes will do the only get the block headers and maybe request for information about a transaction, and then they will request for verification of the Merkle tree and other kinds of things. Okay, so finally, let's look into the network. So basically, there are two types of networks. So one network is the Ethereum main network, right? So this is where all the transactions and smart contracts are running, no doubt about it, right? So when you talk about Ether prices, when you actually execute something which actually creates some financial transaction and things like that, all these things are happening on the main network. So the main network is the primary public Ethereum production blockchain, where actual values are transferred and things like that. So this is like your bank account, right? So this is like a ledger book at your bank containing the accounts of all the customers it has, right? So similar to that, the main network is contains the whole world state. And many times when you develop smart contracts, you have to test them, right? So without any test network, the things cannot happen. So similar to the software development, where we have the production environment, where actual system is running and the actual code is deployed, and you have the staging environment, or you can say test environment, where you will put your components and test the integration and the integration test and the unit testing and other kinds of things. So similar to that, even Ethereum has some test networks. There are two types of networks. One is the Sepolia and the other one is Goerli. So Sepolia is nothing but a copy of the main network. Again, it contains all the existing transactions. So it is also updating its state exactly like what is happening on the main state. So for example, let's say that you have a new block, then it will also add the new block to its network and things like that. So it will give you the latest replica of the main network, right? So for example, you can see how much balance you have in the account and all other kinds of things. The only thing is, it will also, you can also execute transactions, but the transactional state is not updated. So what does it mean? Let's say that I can execute a smart contract transferring 1 Ether from my side to my friend, and I can execute that on the test network. Then it will execute. It will see if the execution goes well and things like that, and other kinds of things. You can test it, but it don't change the balances, right? So the balances will still be the same because it's not an actual transaction. And the other test network, which you use it for developing the test upgrades and also running the validating software. Whenever there are changes, they call it as forks. Fork is nothing but a update to the software and things like that. And whenever there are changes to the software, probably you want to test them, right? Like you want to see that your smart contracts will still behave the same way as you expected with these new rules of changes or something like that. And then what you can do is you can get the Goerli network where you can run this protocol, run your test your smart contracts and also test your validated nodes and all other kinds of things, right? So that's why they have these two networks. Okay, so for any questions? Okay, so how tired are you guys? Because I have few slides, a bit not very technical, but technical. So do you want me to go through them now, or do you want me to go through them next week? It's up to you. I can happily go for half an hour, 45 minutes, but if you are a bit tired, then
Professors, the students, yeah, actually, national level culturals is going on, and
Okay.
I think we can conclude the class. Yeah, we can have these slides for the next class.
Yeah, so let us go through the Hyperledger next time. So
Yeah.
yeah, let's call it a day. Then I will copy the lecture recording and yeah, have the enjoy your cultural festival. Thank you. Bye.